Now expanding the whole of the brackets and taking x1, x2 and x3 common respectively, I get x1 times, this would be x1 times y2 minus y3 plus x2 times of y3 minus y1 plus x3 times of y1 minus y2 is what I get as the entire area. Now because area cannot be negative, there is a possibility that this coordinates may give a negative answer, because the coordinates can be on the left or the right, or can be positive or negative. Negative sign indicates direction, but since they are included in the formula, it may give us a negative area. Therefore, it is always safe that we put modulus for the area. Therefore, this, when reduced to the modulus, I have area of triangle ABC is given by half times mod of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2 of square units, because area is always in the square units. This is how we find area of this triangle ABC using the coordinates x1, y1, x2, y2 and x3, y3. The area of triangle ABC is the derived formula there. Now let's practice one problem on finding the area of triangle, the derived formula which we're going to apply for a given example. Say I take a triangle ABC where each of the coordinates of ABC are given. Say for example, this A is minus 1 minus 1 and B is minus 4 6 and C is minus 3 minus 5. Then let's find the coordinates of ABC using the area of triangle. So with the derived formula, we have to find area of this triangle A, B and C. Now as we know that each of the coordinates is denoted with x1, y1, x2, y2 and x3, y3. Therefore, using the formula for area of triangle, which says area of triangle ABC, which is given by the formula half mod x1 times y2 minus y3 plus x2 times y3 minus y1. So therefore, with this, x3 into y1 minus y2 is what we get the formula for area of triangle. Now substituting each of x1, y1, x2, y2 and x3, y3 in this formula, we get the area of the triangle. So let's see how the substitution is done. Say for example, I have here half mod. My x1 is 1 times y2, which is 6 minus 5. So y2 minus y3 is what I get here. Similarly, my x2, which is minus 4 times y3 minus y1, that is y3 minus y1 is what I get. Similarly, my x3, which is minus 3 times of y1 minus y2, which is y1 minus y2 is what I get overall. Now we should be very careful when we substitute, because negative values have to be carefully taken care of when the substitution is done. This, on further simplification, gives half mod 6 plus 5 is 11 and minus 4 times minus 5 plus 1 is minus 4, and then minus 3 times of minus 7 is what I get in modulus, which on further simplification gives half times mod 11 plus 16 plus 7 3s 21 is what I get. Now this, on further simplification, gives me 21 plus 16, 11 plus 16 is 27, plus 21 is 48. So mod 48 over half is nothing but half times 48, which is 24. Therefore, the area of triangle ABC is said to be 24 units square. So for this triangle, area of triangle ABC is 24 units square using the formula of area of triangle ABC with its respective coordinates is how we understand the area of a triangle with the example problem. So as we have seen the collinearity definition in the previous sessions, collinear points are the points which lie on same straight line. So the points A, B, C are said to be collinear if they lie on same straight line. So let's see how collinearity can be connected with area of triangle. Say for example, I have the triangle ABC. Now this clearly indicates that the vertices ABC are not collinear because A, B, C are not on the same line, though B and C are on the same line. So when does these 3 points become collinear is the biggest question out here. As I see that when this point A lies on BC, then we have this converging to the point A which comes onto BC, so that these 3 points lie on same straight line. Therefore, for the point A to lie on BC, the whole of AC and AB must lie on BC. They should converge to the line BC so that the whole area which is out here diminishes in case of this. So indirectly I understand that if ABC points ABC are collinear, if area of triangle ABC is equal to 0. This is because of this. The condition for collinearity is that the points ABC are collinear if area of triangle ABC is 0, because if the area of triangle ABC is 0, all the points converge on the same line so that the 3 points merge and are collinear, is how we understand the collinearity connected with this formula. So if we find the area of triangle and if I get the area of triangle as 0, that means all 3 points lie on the same line, is how I geometrically understand the collinearity connected with area of triangle. Now let's take an example problem where the area of triangle is ABC is 0. Say for example, I take the triangle ABC with vertices. Say the vertices of this are 3, -2, -2, 8 and 0, 4, then clearly the area of this triangle is 0. Therefore, this triangle has collinear points. So as you can do this using the formula of area of triangle, using area of triangle ABC formula, I can prove that area of triangle ABC is 0, therefore the 3 points are collinear, is how I can identify this problem with connected to collinearity. So this is an example problem which can support the above collinearity using area of triangle. So this triangle with the vertices ABC clearly makes the area 0, as can be solved through the formula which has already been discussed in the previous sessions. And hence, because the area of triangle is 0, I can say the points ABC are collinear, is how I understand collinearity connected to area of triangle equated to 0. Now let's find area of a triangle. Let's revisit the area of the triangle which we have found using the coordinates. Sometimes area of a triangle generally given by, say for example, I have the triangle, this is the base and this is the height, can be found. If the base and height is known, we all know that area of triangle is given by half into base into height, is how we have learned in the lower sessions. But what if the height of the triangle is not given? Say for example, I have a triangle whose height is not given, then how do I find the area of the triangle of that particular dimensions? In that case, where the height is not given, an ancient mathematician called Heron has derived a formula called Heron's formula. And Heron's formula states that is exclusively used only when the sides of the triangle are given, where the height isn't given. So Heron's formula says that if I have a triangle ABC whose sides are A, length B and length C, then I can use the Heron's formula to find the area of this triangle where the height is not given. Only the sides are given here. So for this, the Heron's formula can be used as area of triangle ABC is root of S into S minus A, S minus B into S minus C is the formula where S is A plus B plus C by 2. This is the formula for Heron's, given by Heron. For using the sides, just using the sides, I can find the area of the triangle as root of S into S minus A into S minus B into S minus C, where S is called the semi-perimeter, which is given by S equals A plus B plus C over 2, called the semi-perimeter of triangle ABC, because it is half of the perimeter of triangle, which is A plus B plus C. So S is defined as semi-perimeter of triangle ABC. Heron's formula without the height given of the triangle. So let's find the area of the triangle whose dimensions are given but the height is not given using the Heron's formula. As a practice problem, let's take an example case. So consider a triangle ABC whose dimensions are given as 12, 9 and 15 meters. Now in order to find area of this triangle ABC, I'm going to use Heron's formula where my A is 12 meters because the side A opposite to vertex A is 12 meters. My B is 9 meters and my C is 15 meters. Initially, using the three sides, to find the Heron's formula, I need to first find the semi-perimeter, which is given by the formula A plus B plus C over 2, which in turn, on substitution, gives me 12 plus 9 plus 15 over 2. 21, 36 over 2, which is 18. Therefore, my S here is 18, which I'm going to use along with ABC in finding the area of triangle with the Heron's formula. So area of triangle ABC given by Heron's formula as S times S minus A, S minus B and S minus C on substitution gives me root times S, which is 18 times S minus A, that is 18 minus 12 and 18 minus 9 and 18 minus 15 is what I get here, which on continued simplification On subtraction and multiplying each of the terms, I get this to be root of 18 times 18 minus 12, which is 6, times 18 minus 9, which is 9, and 18 minus 15, which is 3, which on multiplication gives 2916, which is nothing but exactly the square root of 54. Therefore, area of triangle ABC is said to be 54 meters square, is how I calculate using the Heron's formula. So let's continue with the coordinate geometry. The topic for the session is straight lines. Now, as we have already discussed about straight lines in case of the previous sessions, where straight line was defined as a linear polynomial or a linear polynomial equated to 0 in two variables x and y. So let's recap with how a straight line looks on a real xy coordinate system and what is its equation, and then introduce the concept of slope connected with a straight line. So to start with the straight line, a straight line was defined in general form as the linear equation in two variables x and y in the form ax plus by plus c equal to 0. This has been already discussed, where the condition is that a, b, c are all real numbers and a and b are non-zeros. Either a or b are non-zero. One of them should not be 0. So in this case of general form of representing the straight line as ax plus by plus c equal to 0, how does this look on a real xy coordinate system is the biggest question out here. We all know that if, say for example, I take a straight line 2x plus y equals 4, then we all know that this is a straight line with a equal to 2, b equal to 1, and c equals to minus 4, if this is brought to the left. Now for this straight line, for this linear equation, how does this look on a real xy coordinate system? So let's plot the points and see how we get the different coordinates. So when I take here in the tabular form, I just have the set of values taken on in the table. So randomly I take the values of x and y, the first row with x values and the second row with y values, wherein I take x is 0, then y is 0, then minus 1 and 1. So let us randomly take some values for x equal to 0, y 0, or x minus 1 and x equal to 1. These two give me the x-intercept, where this gives me the y-intercept and this gives me the x-intercept, as we have already discussed in the previous sessions. So for finding the y-intercept, I plug in x equal to 0. And when I put x equal to 0 in the equation, I get this to be 2 times of 0 plus y. So on the whole, my y value is 4 when x is 0. Similarly, when my y value is 0, then my x is 2x plus 0, that is 2x equal to 4, such that x equals 2. Similarly, I take x equal to minus 1 as the value assumed there, and then let's see what will be the value of y. So x is minus 1 implies minus 2 times of minus 1 plus y equals 4 from the given equation. So this on further simplification gives y minus 2 brought here 4 plus 2, which is 6. Therefore this gives me the corresponding value is y equal to 6 for x equal to minus 1. Similarly, for x equal to 1, what is the y value? So substituting x equal to 1, 2 times of 1 plus y is 4, which on simplification gives y equals 4 minus 2, which is 2. So these are the values or the points, the 4 respective points which are obtained from the table as 0, 4 is 1 point, 2, 0 is 1, minus 1, 6 is 1, and 1, 2 is another point, which we are going to plot on the real xy coordinate system. So let's see what would be the shape of the figure which is obtained by joining each of the points or as obtained from the table. So in this case, of the 4 points which I have obtained, I plot them on a real xy coordinate system. If this is x-axis and this is y-axis, then I have this as origin and 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, etc. till minus 4. And here I have 1, 2, 3, 4, 5, 6, 7, and minus 1, minus 2, minus 3, minus 4, minus 5, etc. So with suitable scale on x and y axis, let me plot the first point 0, 4. Now 0, 4 is the y-intercept, that is the point where the graph crosses y-axis or cuts y-axis. So we have this 0, 4 here. So this is the point where the given graph 2x plus y equal to 4 cuts y-axis. Is how we understand the y-intercept. Similarly, the x-intercept is 2, 0, which makes me understand that this is the point where the graph cuts x-axis. Therefore, locating the point 2, 0 here, I identify the point here. So this is the point where the graph 2x plus y equal to 4 cuts x-axis and at 4 cuts y-axis respectively. The x-intercept and the y-intercept is how indirectly we understand the concept. Similarly, the next point is minus 1, 6, which clearly comes on the negative side plus this. Is how I get, and then the point 1, 2, which comes as 1, 2 is how I get this. So when I just plot all these points in the graph paper, it is interesting that for a linear equation in two variables x and y, the graph always passes through the points in such a way that is exactly a straight line. You can pass all the points through a ruler or a scale which is put on the graph sheet. So this is exactly a straight line, is how we understand the concept of graphs. So the equation of this linear equation in two variables 2x and y is a straight line. So this will be a straight line, is how we understand in the coordinate geometry concept. A straight line is nothing but a linear equation in two variables x and y, or vice versa. And using this, the different points, I locate the x-intercept is 2 and my y-intercept is 4, and it passes through many points. Now say for example, randomly I wanted to find the point, at x equal to 3, what is my y? I wanted to know the value of y when x is equal to 3. So if I wanted to find the value of y corresponding to x equal to 3 using the straight line, then I identify that for x equal to 3 on this graph, exactly which is perpendicular, this would be somewhere here. So let's see what exactly is the value of y I obtain from the algebraic simplification. So when I take x equal to 3, 2 times of 3 plus y equals 4, that implies y equals 4 minus 6, which is minus 2. So therefore clearly when x is 3, I know that my value of y is minus 2. Sometimes to avoid this simplification, the graph helps me in finding the values of y when I know the value of x from the graph sheet. Or I can find the value of x when I know the value of y respectively from the graph sheet. If I know the value of y is minus 4, then my value of x is somewhat as 4, is how I understand the concept. So different values of x and y are just nothing but passing in this form. So this is how I get the different x and y values associated with each other with respect to the line 2x plus y equal to 4, which is a straight line. In this case, x equal to 3 giving me the corresponding value of y as minus 2 from the graph paper, which can be verified from the simplification which gives me exactly y equals minus 2. Is how we can verify, but the advantage of the graph is that we can find as many number of x and y coordinates on the given graph by using the relation from the graph. In this case of a straight line, this giving me the value for corresponding to x equal to 3 is how I understand the straight lines connected with the coordinate system. Now the next topic of the session is about the slope of a straight line. Now that we have understood a straight line being a linear equation in two variables x and y, now next comes the understanding of slope of a straight line. So what is a slope in general sense? Slope in general sense is understood as the steepness, which is the other name for slope in the English context of the dictionary. So when I say the slope, it is the steepness of the given concept. Say for example, I say slope of a straight line is nothing but the steepness of a straight line along the ground. So to come out with a real life example, let's come with a slider. Say for example, I take a slider, which there are two types of sliders I consider here. One of the slider is this is the ground and this is the slider. Say this is the slider, slider 1, which I have considered here, and in this case let me consider the slider 2. And this is considered to be the slider 2. Now as we can clearly see from these two sliders, which of the slider is more steeper is the question out here. We can clearly see that this is more steeper than this. Mathematically, what makes us understand that this slider has more slope or is more steeper than this slider is how we understand the slope in general sense connected with mathematics. In mathematics, we say that this slider is more steeper than this slider, that is the slider 2 is more steeper than the slider 1 based on the angle which it makes with the ground. Say for example, this makes an angle theta 1 and this makes an angle theta 2, then clearly I see that this angle is greater than this because this is raised at a more steeper height. So this makes more angle and this makes lesser angle because this is tending towards the ground and this is moving away from the ground. This is how we understand. Therefore, since theta 1 is less than theta 2, that implies slider 2 is more steeper than slider 1, is how we connect the angle with the slope or steepness of a given straight line or a slider. So in similar manners, if I consider the slider to be a straight line on an xy coordinate system, then more the steeper, more is the slope, or more the angle made with respect to x-axis, we say more is the steeper or more is the slope of the given straight line, is how we connect the slider with a straight line in mathematics. So since here theta 1 is less than theta 2 implies slider 2 is more steeper than slider 1 and hence its slope is how we understand in the real life imagination. So hence, with the concept of slope understood with respect to a slider, then in this case we mathematically derive the formula for a slider. So we have a mathematical formula for a slope defined as change in y by change in x. That is, as the x coordinates, y coordinates change, even the respective x coordinates change, then the difference of y coordinates by the change or the difference in x coordinates will define the slope. So slope is defined as change in y by change in x, is how we understand mathematically the slope of a straight line. Next. So therefore, if I have two lines, I have a line with 2 points A and B connected, where the coordinates of A are x1, y1 and the coordinates of B are x2, y2, then my change in y would be y2 minus y1 and change in x would be x2 minus x1 or x1 minus x2 respectively. Therefore, for a slope of this straight line, using the formula of slope would nothing be change in y, which is y2 minus y1 by change in x, as I can see with the formula, is x2 minus x1, is how we connect the slope with the coordinates as the formula. So therefore, when I have two coordinates given, I can find the slope of the straight line using this formula, is how we understand the slope using the coordinates. So let's see an example problem where we find the slope for a given line passing through two different points. So let's find the slope of a straight line. Say for example, I have a straight line passing through 2 points P, which is 2, 3, and Q, which is 4, 5. Now how do I find the slope of this line segment PQ? So as we know that if I assume the first coordinate as x1 and y1 and my second coordinate as x2 and y2, then the slope of a straight line joining the points x1, y1 and x2, y2 is given by slope, generally denoted by m, is given by the formula change in y by change in x, is what is the derived formula, so that on substitution of y2 and y1, this reduces to 5 minus 3 by x2, which is 4, and x1, so 4 minus 2 comes in the denominator. This is how we substitute the values of x1, y1 and x2, y2 correspondingly to find the slope using this formula. So on further simplification, this reduces to 5 minus 3, which is 2, and 4 minus 2, which is 2, which on cancellation gives me 1. Therefore, the slope of a straight line joining P and Q is said to be 1. That is, the slope of this straight line is said to be 1 using the formula. Is how we understand the slope of line joining 2 points x1, y1 and x2, y2. Now let's see how the slope is connected with angle. As we revisit with the example problem of a slider, we have seen that more the angle made by the slider, more is the steepness and hence the angle. Therefore, they are directly proportional, where lesser the angle, lesser is the steepness and less is the slope of that given slider or a straight line. So to come with this, how do we understand the formula connecting the slope and the angle? So this has to be done through a derivation on an xy coordinate system. So let's consider an xy coordinate system with x-axis, y-axis and origin. Now from this, let me take an angle, let me take a straight line in this xy coordinate system making an angle theta, because I have to connect slope with theta. So let me assume that that line makes an angle theta with the x-axis in the anti-clockwise direction. So if I take the straight line, so L is the straight line which makes an angle theta in with x-axis in the anti-clockwise direction. So let's consider two coordinates A and B on the line L. So the point A, which is here, is with coordinates x1 and y1, and the point B with coordinates x2, y2 is on the line L here. Now I wanted to find the slope connected with the angle theta which is making with x-axis. So therefore, in order to do that, let me drop a perpendicular on A and on B onto x-axis here. And let's drop a perpendicular from A onto this. So let me take this as C, D, and E is how we get the diagram when I drop the perpendiculars respectively from A and B and A onto E. Now from this, clearly what would be the length AE is the biggest question here. So in this case, now because I drop a perpendicular here, this x coordinate will be nothing but the distance from O to D. And similarly, because the distance from O to C is nothing but the x coordinate of B, which is x2, therefore this on the whole is x2, so that this and this are equal, and OC is nothing but OC minus OD gives me DC. As I clearly see here, my DC is OC minus OD. When I subtract, I get DC. Therefore, OC being x2, x2 minus x1 is DC, which indirectly is AE. So this comes out to be x2 minus x1, which is also x2 minus x1 here, because this is OC minus OD is DC equal to AE, is how we understand geometrically this part. Similarly, when I drop the perpendiculars onto y-axis, the same concept arises here, where if I wanted to find the length BE is nothing but the whole of BC is nothing but the y-coordinate of this, which is y2, and the y-coordinate of this, which is this, is y1, and therefore BE is nothing but BC minus EC is BE, but because this is equal to this, y2 minus y1 is this, which is equal to this. So this BE would be equal to the whole of y2 minus y1, which gives me y2 minus y1 as the measurement. So I get this to be y2 minus y1 and this to be x2 minus x1 in a right angle triangle AEB. Now because this is theta, this will also be theta because these two lines are parallel, therefore these two are the corresponding angles. So two corresponding angles are always equal in the pair of parallel lines. Now since the lines are parallel, the corresponding angles are equal, and therefore this being theta, this will also be theta. Now if I take this diagram separately as a right angle triangle, I clearly understand that the triangle with measurements, let me take this AEB as taken here, AEB is a right angle triangle as can be taken from here. Now in this right angle triangle AEB, the angle here is theta, and this is x2 minus x1, and this is y2 minus y1 is what we get here. Now from this, we know that in a right angle triangle, if we revisit the trigonometry concept, tan theta is opposite by adjacent. Therefore, using tan theta, I get tan theta is opposite side by adjacent side. Therefore, my opposite side to angle theta is exactly EB, which is y2 minus y1. Therefore, I get this as y2 minus y1. And my adjacent side, which is this, is x2 minus x1, which on substitution gives x2 minus x1. Therefore, tan theta is y2 minus y1 by x2 minus x1. But we have already derived the formula for slope, which is y2 minus y1 by x2 minus x1, or change in y by change in x. Therefore, if I just connect this with the slope, I assume that my slope is nothing but the tan theta or this. Therefore, my conclusion comes that the final conclusion is that the slope M, which I generally denote for the slope, is nothing but tangent of the angle theta, which is made with x-axis in the anti-clockwise direction, and nothing but this. So this is how I obtain the formula for slope using angle. If I know the angle, I use this formula. If I know the coordinates, I use this formula respectively, depending on the conditions given in finding the slope. But the slope is tan theta or change in y by change in x. So this is how the slope and theta are connected. Slope is tangent of the angle made by the line with x-axis in the anti-clockwise direction, this being the angle.